With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A block of mass m starts at a height on a frictionless inclined plane. That height is h. The block slides down the plane, travels across a rough horizontal surface with coefficient of kinetic friction mu, and compresses a spring with force constant k a distance x before momentarily coming to rest. Then the spring extends and the block travels back across the rough surface, sliding up the plane. The block travels a total distance d on rough horizontal surface. The correct expression for the maximum height h dash that the block reaches on its return should be. So this block initially was at some height h, which means it has its potential energy Pe is equal to mgh. Now it traveled across this rough plane. Due to this rough plane, there was energy lost due to friction. Now what will be this energy that was lost? This energy will be equal to work done against force of friction. So let's try to find this work done against friction. So let's say WDF will be equal to force of friction FV times the displacement D. Now force of friction FV will be equal to mu times the normal into the distance D that was traveled. Into the distance D that was traveled. And this normal will be equal to, this normal force will be equal to the weight of the block, which is mg. So mu mgd is equal to work done due to friction, which is also equal to the energy lost. So that means if I apply the principle of conservation of energy, final energy will be equal to initial minus the energy that was lost. Now final energy will be only the potential energy that is due to the height h dash. So mgh dash will be equal to initial energy was only due to potential energy due to height h. So mgh minus the energy lost is due to the work against friction, which is mu mg D. So this is our answer. That means the correct answer is option number 1.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.